Hello, my name is Sothea. I am a student of Paragon International University, and I am in the civil engineering. I would like to welcome you back to another video. And for this video, I would like to tackle another section from the book Thomas Calculus 12th edition. That being section 14.10, talking about partial derivatives with constrained variables. So on today's agenda, there is 3 sections to cover. The first section will be about explaining partial derivatives. Basically, I'll just be explaining and briefing about what partial derivatives are. The second section will be about talking about constrained variables and the chain rule. I will be explaining what a constrained variable is and how to use the chain rule to help solve with partial derivative problems. Third and last section will be about basically just solving a few problems relating to partial derivatives with constrained variables in hopes of being able to help you guys grasp the concept a little bit more. Now that we've gotten that out of the way, let's move on to the first section of the video. What is partial derivatives? Partial derivatives is a method of derivation used to derive a function with multiple variables by holding some variables as a constant. So if you're given a function f of x and y, and you want to derive it partially, that means that you will have to hold one of the variables as a constant, meaning that if you're deriving it partially, for example, keeping x constant, meaning that you derive y, but you keep x a constant. So you will come across some notations that will basically come across during doing problems, partial derivative problems. So for this one, basically means that you derive f in respects to x while keeping every other variable in that function a constant. And for this one, same concept as this one, you derive f by y and keeping every other variable in that function a constant. For this one, you'd basically derive f by x as well, but you do it twice, and you keep both times you keep every other variable as a constant. And for this one, you derive the function f by y 2 times, and again, both times you keep every other variable other than y a constant. And for this one, it basically means that, for this notation, it basically means that you will derive the function first by x, keeping every other variable a constant, and then you will take that answer of derivation and you derive it by y. And if there are any other variables left, you will also keep that a constant other than y. And for this one is basically the opposite of this one. You first derive it by y, keeping every other variable a constant, and then you take that and derive it by x, and then keep every other variable a constant. So for an example, you're given z equals 3x squared y to the power of 4 minus 5x to the power of 7 plus 4y to the power of 8. And we can see that z is a function of f. Z is a function of x and y, basically means a function of x and y. And we will have to find dz over dx and dz over dy. So we see that if we derive z in respect of x, that means we'll have to keep every other constant variable, and that in this case will be y. So 6. So for this one, we will keep y a constant, and we will be deriving x squared, 3x squared by x, and we will get 6x y to the power of 4 minus this one. We will derive it by x as usual. It will be equal to minus 35x to the power of 6. And then for this one, since we keep y as a variable, we keep y as a constant, this section here is a constant. So if we derive it by x, this will equal to 0 because there is no x variable. And for this one, dz over dy, it will equal 12x squared y cubed because we derivated this function z by y, and this one we keep x squared, constant and 3y to the power of 4. We derivate that and we get 12x squared y cubed. And for this one, since there is no y variable and x is a constant, this is a constant and will be equal to 0. And this one will derivate normally by y. It will equal to 32 plus 32y to the power of 7. So now we will talk about constrained variables. A constrained variable, as the name implies, is a variable that is being constrained by another variable or a set of variables. For example, in this instance, they give a function w equals x squared plus y squared plus z squared, and z equals x squared plus y squared. This means that in this relation here, z is being constrained by two variables, x and y, and that's what it means by a constrained variable. Now, the chain rule. The chain rule is a rule that can be used to solve problems containing partial derivatives with constrained variables. As we see in this problem, we're given w equals 2x squared plus 3y squared plus z squared, and the constraint relation is z equals squared plus 2y squared, and we will have to find dw over dy while keeping z a constant. And this means that we will find dw over dy, and we will be keeping z a constant. So we can break down this in by using the chain rule, and this will then dw over dy, because keeping z a constant, will equal to dw over dx times dx over dy plus dw over dy plus dw over dz times dz over dy. To help with understanding partial derivatives of constrained variables, here are some example problems to get you accustomed to it. For this one, it's the previous problem. So dw equals 2x squared plus 3y squared plus z squared, and so on, similar to the previous problem. And we will use the chain rule as this previous problem, but you will see there are two missing here, and that will be dw over dz times dz over dy. And it's missing because we can see here that we're keeping z a constant. So that will mean if we derivate dz by dy, that means that, and since z is a constant, that means that this will equal to 0. So this will all equal to 0. That's why this is gone. So now we will solve for dw over dx. We'll basically just derivate dw. We will basically derivate w by x, keeping everything else a constant, meaning that this will equal to 0, and this one will just be 4x. And to find dw over dy, we derivate w in respects to y, keeping everything else a constant. So this will be 0, this will be 0, and this one we derivate normally by y, so it will be 6y. And we're missing one more, dx over dy. So we look at this relation here, z equals x squared plus 2y squared. And you would just derivate both sides. dz over dy equals 2x plus 2x times dx over dy, because we derivate x squared by y using the chain rule. And for this one, we derivate by y as well, so it will be 4y plus 4y. But we established up here that z is a constant. That means that dz over dy equals 0, meaning that this will all equal to 0, like right here. And then we can just do a simple algebra, and then we can find dx over dy, and it'll equal to minus 2y over x. And we can just plug these answers into the chain rule to find the answer we want. And dw over dy, keeping z a constant, will equal to minus 2y. Another problem here, w equals 2x squared plus y minus 4z plus cosine t. Here we can see that there are 4 variables in this function. And it gives us x minus y equals t. And they want us to find dw over dt, keeping x and z a constant. So again, using the chain rule, we can break it down to dw over dx times dx over dt plus dw over dy times dy over dt, dw plus dw over dz times dz over dt plus dw over dt. Since x, z are constants, that means that these, dx over dt and dz over dt will be equal to 0. And to find dw over dt, we just derivate this function by t, and we will get minus sine t, dw over dy, we just derivated by y, and we will get 1. And to find this, we have to look at this relation and derivate both sides. Dx over dt minus dy over dt equals 1. But we've established here dx over dt equals 0. That means dy equals dt equals 1. And we just plug all these in, and then we will equal 1 minus sine t. We are now at the end of this video, and as a closing remark, I would like to thank everyone for watching and hope I have been able to help you understand the concept of partial derivatives with constraints variables a little bit more. Yata, I would like to wish you a wonderful day.